Hello and welcome to this video where I will be going over introspector.ossfuzz.com, which is a website that can give you a lot of insights about the open source fuzzing status of various open source software. So it's kind of a front end to OSSFuzz, where OSSFuzz is a service for continuous fuzzing of open source software. And it's a front end in the sense that it takes data from the projects integrated into OSSFuzz and shows various fuzzing metric about these projects. And it does that by way of the Fuzz Introspector tool, which is a website for kind of like introspecting the fuzzing of a given project. So it can give you a lot of insights about how well a project is being fuzzed, what are some new entry points, and so on. So the website can be used for various things. In particular, it can answer questions such as what software is actually being fuzzed in OSSFuzz, how well is a given project being fuzzed, which parts of a given project is fuzzed, and that goes down to the sort of very specific source code lines, which lines of code are actually being fuzzed. And then it can also give insights about what are some interesting parts of a code that might not be fuzzed, but are good targets for actually fuzzing. So the website itself shows data of almost all projects in OSSFuzz. So OSSFuzz has 1,185 projects integrated, and this website shows data about 969 of those. And the reason is that some of them might not be building correctly, and also some of them might not have code coverage builds, and so on. And at the front page of the website, you see stuff such as macro insights into the various open source projects and the progress over time. So for example, you can see the number of projects currently being analyzed by this website, which is today 969, and you can see how it increases over time, which is roughly in parallel with new projects being integrated into OSSFuzz. The significant jumps you see here is a consequence of when this website was being developed. It added support for projects in certain programming languages. So it didn't have support for all programming languages at first, but then that came later, and that's why you see these significant jumps. So it's kind of here you'll see a lot more stable progress. It can show status such as how many fuzzers are being analyzed, so how many harnesses. And currently there is around 5,000 harnesses in the database of this website. And there's also some metric about the lines of code being sort of involved in the analysis of this website, which is currently 77 million lines of code. And of those 77 million lines of code, 15 million lines of them have actual code coverage within OSSFuzz, meaning that there are actually a harness that hits some of these lines of code, which almost gets up to, well, it does get just to 15 million lines of code. The website itself has 4 main pages. The first page, project overview, shows you a high-level status of each of the projects, each of the 970 projects shown on the website, including the name of the project, the language, the number of fuzzing harnesses in this project, the runtime code coverage which is a percentage of the given project, the total lines of code in the project, as well as the total lines of code being having runtime coverage. And we can sort this to just very quickly find a given project. And there's also a convenient search box here, which you can use to quickly find an open source project. Well, the second main page of this website is a function database that allows you to search for any function name that may exist amongst these 969 projects. And as shown on the front page, there is around 1.4 million functions indexed on this website. And we can search for any name here and give sort of like further links that has a lot more detail about whether a given function is being fuzzed or not. We then have the third page called indexing status. And this page is used to show the build status of various open source projects. And in short, this is needed to understand if, for example, you expect a project to be integrated into this. So if you have a project on OSS Fuzz that is running on OSS Fuzz but might not be shown up on this website, it's likely because its coverage build status is failing. So there are some that are failing, and there are some that are, and there are many that are, well, succeeding. But in order for it to be shown in this project overview page, the code coverage report has to be working. And there are like logs for convenience that shows the build log of a given project, where you can then go in and, so for example, we can look at the log here to identify the failed issue, and then we can go to the OSS Fuzz project and fix the given build.sh, which has the build instructions for the project. The fourth page on this website is the API page, which is essentially just some documentation for various APIs that are exposed from this website. And these APIs are used to essentially can extract all or serve all the information that is also shown on the website, which is very useful for example, building tools that automatically check certain fuzzing aspects of a given project or any given project. So it can, for example, there's a summary API, and you just give the project name as argument, and it can show you stuff such as what, like the specific code coverage of the project. It can tell you stuff such as how many the specific fuzzing harnesses in the given project, and sort of a lot of detailed information when it comes down to it. And there are various other APIs that makes it very convenient to build your own tools that can reason about the status of fuzzing open source projects. So we're now in the project's overview page, and this is usually the page where I spend where I most always start. So I'd like to show what information we can extract of a given project. And in this case, I'd like to use the libwebp project, which we can see here. It has 8 fuzzing harnesses integrated into it. It's in C++ and has runtime coverage of around a bit more than 80%. And we can also see information about the total lines of code. We can click on it, and we now have information about the sort of summary information. We have data about its historical progression. So we can see that recently a new fuzzing harness was added, but we can also see that the code coverage has been fairly stable for quite a while. We then also have a section that shows functions that might be interesting to target in this project. And this is largely based on how complex, how much sort of control flow exists within the call tree of a given function, in combination with a given function having 0% code coverage. So we have both a link to the OSS Fuzz project here, and this is useful because it makes it very fast to see how a given project is being built, references to, for example, which repositories are used to like the source code, where the source code comes from for this given project. We have links to the build logs, which in most cases is not necessarily needed. It's only needed when things go wrong and the build is not succeeding. Then it's very convenient to quickly see the issues at hand. We have summary information about the code coverage of the project. We have the fuzzing harness count here. And then we have some information about static reachability, which shows sort of the size of the control flow graphs relative to the project size of the fuzzing harnesses. And we then have linked to the code coverage report as well as the fuzz introspector reports. And in this case, the code coverage reports are code coverage reports that show details down to the very sort of source code level each like lines of source code, meaning we can see which lines are actually being executed. So these aren't by the fuzzing harnesses, and which lines are, which makes it very detailed once we start looking at once we start to want to pinpoint what parts of a project are not being fuzzed. We also have links to the fuzz introspector report, which can be used to quickly understand, for example, which lines are not being hit. So here we have all the lines of all the sort of functions in the project that has 0% code coverage. We can sort by accumulated cyclomatic complexity, which then gives us both links as well as which gives us the most complex functions that has 0% code coverage, and we can click on them to find the exact. Let me find a bit better one. We can click on them to find the sort of exact location in the source code where we can see that there's no code coverage of this function. And we have kind of some similar data down here, similar to what I just showed you in the fuzz introspector report, that gives us information about which are the functions in the project that doesn't have code coverage but has a lot of logic attached to it. So we can, for example, quickly see the encode function in the project doesn't have any code coverage, and we can do the exact same with the other functions here. Let me just see if we can find some that are not necessarily macros. I think this one is another example of a function that opens up to a lot more code and has 0% code coverage. So these we argue are good targets for fuzzing. It might not, and it's only a metric of how complex and how much code the functions involve, not necessarily that these functions are on the attack surface of a given threat model in that sense. So that's how you can see an overview of a given open source project very quickly, and you can very quickly identify what are what parts of the project is being fuzzed. And you can also very quickly identify what parts of a project is not being fuzzed, even when you just look at this sort of code coverage report. So for example, we can see that this function, this source file has around 80% code coverage, line code coverage. And we can try to identify what is not being covered. And we see, for example, this function here is not being covered. And let me just copy the name of this and then move on to the second function, the second main page on introspector.ossfuzz.com. And we can try and search for this function name. And we can see that two projects actually have this function in their source code, OpenCV as well as libwebp. So the reason OpenCV has it, if we click on the function, first and foremost, we can see it has 0% code coverage. But we can see the path of the file in which the function is defined within the OpenCV project right here. And so this is the path of the file on the file system that OSSFuzz uses to build the project. And we can see that it exists within the OpenCV folder and then third-party libwebp. So the point here is that OpenCV itself uses libwebp and in that way has it involved in its project. And if we click on it here, we then get the code coverage report for the OpenCV project, not for the libwebp project, and we can indeed see it has no code coverage as well there. And we can also click on the function as it exists in the libwebp project, and we get the same information that I have just shown previously from a different angle. So here, if we click this link here, we get to the code coverage report as it exists in the libwebp project. Interestingly, we can see that the function itself actually exists in the control flow graph of several fuzzes that exist in the libwebp project. So in theory, there might be some assumption that this function should be analyzed, but currently has 0% code coverage. And we can then have a convenient link back to the project the project page that I showed previously. We can also sort of try and go into the function database and try and search for, so if we just want to, let's say, add a fuzzer, add a harness to a random open source project, and we'd just like to find an interesting function to fuzz. One way is just to search for some interesting function names here and maybe find some inspiration to some targets. So if we search here for, let's say, load image, that would be a convenient way to fuzz something where we can have the image be our seeded by our fuzzer. We can see that, for example, MuPDF here has a function called XPS load image that has 0% code coverage. So we can click on this function and we can then go into the code coverage of the function just to see. Indeed, it does not have any code coverage in the MuPDF coverage report. But we can also see that the function itself is actually just a wrapper around another function, fset new image from buffer. And what we can try is we can search for the function here, and we see that there is we don't have it here, so it's not in the same file. And instead of having to go and find the function one way or the other, we can actually just go into the function database and search for that function here. And we can see that indeed there is a function in MuPDF, and it actually has 71% code coverage, which means that although so we have this right here, and this essentially means that even though there was no code coverage of this function that calls into the function, this one is actually not that interesting in the sense that the function is already being fuzzed. The function that it is just a wrapper around is already being fuzzed. So this is a way to very quickly understand interesting new targets to fuzz for a given project. And I use libwebp as an example. And there's a lot more detail that you can extract from these. This functions of interest to fuzz section is very useful to find new targets of any given OSS fuzz project. But you can also get a lot more details about the fuzzing status using these fuzz introspector reports. But I'm going to go over that, especially this project functions overview table has a ton of information that you can use to very quickly identify good targets. But I'm going to go over that in a separate video and will not go into detail here. So this is introspector.ossfuzz.com, which is a website that simply shows a lot of visualization, a lot of metrics, a lot of analysis of the projects integrated into the OSS Fuzz open source fuzzing service. I hope you enjoyed watching and have a good day.